This is section 2.2, estimating limits. So if you remember back to the last section, we were asked to estimate the instantaneous rate of change at a specific point. And remember, whenever we saw instantaneous rate of change, that made us think of slope. We had to plug in values closer to our point of interest and calculate the slope between those points. Well, in this section, they're asking us to estimate the limit. And really what the limit means is what value is the function approaching at this x value that they're interested in. And really, the way that we solve these types of problems is really similar to the way we solved them in the last section. So let's go ahead and go through an example problem. This is number 19 in your book. It's asking for the limit as x approaches 2 of this whole function here. Okay, so remember we solved these really similar to the way we solved the last section. And if you remember back to the last section, our first step was we want to make a table. We're interested in what this function is doing as the x values are getting closer and closer to 2. So we'll make a table and plug in values closer to 2 from both sides. So I went ahead, already made this table, but if we were to go through an example step, let's say we plugged in 1.9, we would plug 1.9 into our function wherever we saw an x. I'm not going to go through each step because that would take a really long time, but when you plug in 1.9, you get 1.689655. So let's go ahead and put that in our table. And like we were just saying, these problems are pretty tedious. They take a pretty long time to do, but this is preparing you for later sections where we'll learn the actual math way to solve these problems. And once you get used to that method, it actually makes these problems a lot easier. Okay, so plugged in 1.9 into our function, got this output value. From here, let's go on to step 2. Step 2 is look at it. We're just going to look at this table and see what values it's getting closer to. So as our x values got closer and closer to 2 from both sides, if we were to look at the y values, we see that they're approaching about 1.666 from both the left and the right. So that means that the limit as x approaches 2, since both sides are approaching the same value, you can say the limit as x approaches 2 of this function is about 1.666. And that's your final answer.